Hello everybody, welcome into another lesson. Today we are going to talk about negative exponents. So, negative exponents are actually easy enough to understand. Let's say I have any arbitrary number or variable a to the negative m power, which would be to any negative power. What that is going to be equal to is simply 1 over a to the positive m power, or 1 over that number of variable to the positive m power, or whatever power it is. So let's say, for example, I have 4 to the negative first power. So I got 4 to the negative first power. That is simply 1 over 4 to the first power. You're simply going to move that base to the denominator with a numerator of 1, and you'll make it a positive power in the denominator, so the answer would just simply be 1/4. 1 over 4 to the first, or simply 1/4. Alright. I have 5 to the negative third power. So 5 to the negative 3 is nothing more than simply moving that 5 to the negative 3, you move it to the denominator, you'll have a numerator of 1 by default. In your denominator, you'll have 5 to the positive 3 power. So if you have a negative power, you simply move the base and the exponent into the denominator, and you make the power positive in the denominator. So that's nothing more than simply 1 over 5 to the positive third power. That's all a negative exponent does. We'll do some more examples here. We have the quantity of negative 6, that's to the negative second power. So we have negative 6 to the negative second power. That's nothing more than making a numerator of 1 and putting that negative 6 to the negative second power in the denominator. So negative 6 will go in the denominator. That negative 2 will become positive 2 in the denominator. So you'll have 1 over negative 6 to the positive second power. Alright. Let's see, I have 3 to the negative fifth power. So we got 3 to the negative fifth. Well, of course, the default numerator is 1. I'm going to move that 3 to the negative fifth into the denominator. I'll move that 3 to the denominator. I'll make that negative 5 power a positive 5 in the denominator. So the answer is going to be 1 over 3 to the fifth. That would be the answer for 3 to the negative fifth. Alright, then we have, of course, 10 to the negative fourth. So we got 10 to the negative fourth. Well, numerator is going to be 1. You move that base 10 to the denominator. Then the exponent of negative 4, you make that positive 4 in the denominator. So my answer is going to be 1 over 10 to the fourth. That's the answer I would get for 10 to the negative fourth, is 1 over 10 to the positive fourth. Alright, finally we got a variable. We have p to the negative first. Alright, so I got p to the negative first. Well, I'm simply going to have a numerator of 1. I'm going to move that base p to the denominator. I'm going to make that negative 1 into a positive 1 in the denominator. That'd be 1 over p to the first, or simply 1 over p. So the answer will be 1 over p. Alright, now let's say hypothetically they gave me this. 5p to the negative second. Well, suddenly on this monomial we have a coefficient that's not 1. We have a coefficient other than 1, that's 5. If you have a coefficient that's not 1, that coefficient, which in this case is 5, becomes your numerator. then that p, that goes into the denominator, and still that negative second power becomes a positive second power in the denominator. So what you would get is 5 over p to the second power for your answer. All right. I have a to the negative 10th. So I have a to the negative 10th power. Well, my coefficient's 1, so my numerator is going to be 1. My denominator will be that base a, and then that negative 10th power will become a positive 10th power in the denominator, so I'll get 1 over a to the 10th power. Yeah, negative exponents, there really isn't a whole heck of a lot to it, honestly. So how about 21r to the negative 20th? What if I gave you one like 21r to the negative 20th? Well, we have a coefficient other than 1. That coefficient will be your numerator. You'll have 21 in your numerator. In your denominator, you'll have that base r. And then that negative 20th power becomes a positive 20th power in the denominator. So you would have 21 over r to the 20th power. That would be how you would rewrite that. Okay, that isn't so bad, is it? That isn't so bad. Now we're going to work in reverse. Let's say I have 1 over 9 to the 4th. I have 1 over 9 to the 4th. Well, anytime I have a power, I just have a numerator that has a regular number. I have a denominator that has a base to a power. What you're going to do, if you wanted to convert this into an exponent, you would take your base 9. That 4, since it's in the denominator, will become a negative 4. So simply you would have 9 to the negative 4th power. That would be your answer. All right, let's say you have 1 over 5 to the 5th power. Well, my numerator is 1, so we're good there. In my denominator, though, I have a power in the denominator, just only in the denominator. So what I'm going to do is take that base 5, and that 5th power that's in the denominator, that's just going to turn into the negative 5th power. So the answer here is going to be 5 to the negative 5th power. All right, so now I have 1 over 8 to the 3rd. I got 1 over 8 to the 3rd. Well, since the base and exponent are in the denominator, what you're going to do is take that base, then that third power, that positive third power that's in the denominator, you're simply just going to make that a negative third power. So you would just have 8 to the negative third power. That would be your answer. All right, let's say I have 1 over 13 squared. 1 over 13 to the 2nd power. Well, we see we have a base and a power by itself in the denominator. So what you got to do is take that base of 13 that's in the denominator. Then you have a positive 2 in the denominator. You got to make that a negative 2. So this is the same as 13 to the negative 2nd power. All right, let's say we have 1 all over q to the 7th. So I'm going to give you 1 all over q to the 7th. All right. Well, we see we have a base and an exponent by itself in the denominator. So what you're going to do is, of course, you're going to make your base q, but you have the power of 7 in the denominator. This is just going to become a power of negative 7. So 1 over q to the 7th is going to be q to the negative 7th. That's exactly what you get, is q to the negative 7th. Now let's take that same one. Let's say I had 3 over q to the 7th. What happens then if my numerator is any other coefficient other than 1? In your numerator, if your coefficient is anything other than 1, first thing you're going to do is you'll write it as your coefficient. So you'll have 3 times the base q, which is in the denominator, and then that 7th power that's in the denominator becomes the negative 7th. So the answer I'd be looking for here is 3q to the negative 7th. And I got more examples. Alright, let's say I have 1 over z to the 9th. I have 1 over z to the 9th. Well, in the numerator, I just have 1. I just have 1, so that's easy. We don't have to worry about any coefficients since it's 1 in the numerator. But in the denominator, you have z to the 9th. You'll take your base z. You have a positive 9 in the denominator. You would make this just to the negative 9th. So your answer is going to be z to the negative 9th. Okay. Let's say I have 13 over c to the 15th. So I have 13 over c to the 15th. Well, of course, this time in the numerator, I have a number that's not 1. So first thing I'm going to do is bring out my number, 13. I'm going to multiply that times my base c that's in the denominator. And then I have a positive 15th in the denominator for my power. That's just going to become to the negative 15th for the power. So the answer we'd be looking for here is 13c to the negative 15th power. Alright, let's do two more here. So let's say I have 31 over m to the 8th. I have 31 over m to the 8th. Well, my coefficient, my numerator is something other than 1. It's another number other than 1. So first thing I'm going to do, write my number that's other than 1, which is 31 in this case. I'll write the 31. Then I'll multiply that by my base m. And then you have to the 8th in the denominator, which means it's to the negative 8th power. So the answer we'd be looking for here is 31m to the negative 8th power. One more here, and I'm going to explain it. What if we had 1 over m to the negative 2nd? This time we have the negative exponent in the denominator. Well, how are we going to handle that? It's going to be simple. We're just going to move the m up to the numerator, and you'll have a positive 2nd. So you'll make that negative 2, it's in the denominator, you'll just make that a positive 2. So the answer is just simply m to the 2nd. So if you have a negative exponent in the denominator, it just simply becomes a positive exponent up in the numerator or up top. That's all that is. I suppose we'll do one more example here. Let's say I have 1 over f to the negative 9th. I have 1 over f to the negative 9th. Well, of course, my numerator is 1, so I have no coefficients to worry about, but I'll make f my base, of course, like it is in the denominator. Since you have negative 9 in the denominator as your power, it becomes positive 9. So the answer I'd be looking for is f to the 9th. So really, negative exponents are actually quite simple, as you can see. But we're going to apply this into something greater. In the next lesson, we are going to learn scientific notation, which will teach you how to write really big numbers or really big decimal numbers in a much simpler format. It's used a lot in chemistry and biology and physics and other applications. So stay tuned for the next lesson to be scientific notation. I hope everyone has a good night. Take care.